over long division of polynomials kind of quickly. We'll do a couple examples. This is section 3.3 stuff. I can't say it's my favorite thing because they're long problems and you don't use them often enough to really get good at it. You will need them here and there, so we'll discuss them now. First thing first, I want to point out that there's three different forms in which you could ask a problem like this. There's this one, writing it as just a rational function. There's this one, where you're just writing it as a division, or this one. All three of these mean essentially the same thing. You're going to divide this term by this term, or this polynomial by this polynomial. Now, I sometimes suggest that these things can be memorized as a series of steps. That'd be father, mother, sister, brother, and then if you have a dog, Rufus maybe, repeat, etc. But the father step would be kind of like your figure step. You figure out, well, what are you going to multiply this by to get this? Now we're just looking at the leading coefficients here. So you're just looking at the 2a and the 8a squared. If that's not something you can do in your head, that's fine. Just do a little division. Take this divided by this, and that's your 4a, so that'd be your father step, where you figure things out. And then the mother step is right here, where you multiply that 4a times this stuff here. Now that 4a, I should mention, goes on top. So there's your 4a. We'll take that 4a times 2a minus 1. You get 4a, or 8a squared minus 4a. That 8a squared minus 4a is going to go right underneath, and then you're going to subtract. So that's the next step. Father, mother, sister. Sister would be subtract. Now there's one little tricky part about the subtraction, and that is you've got to change the signs and add. So a lot of people are good at subtracting this and this, but then they'll do something funky here. The way I work around this so that it's a little bit more straightforward is I change the signs and add. So I make that a plus, that becomes a minus, that becomes a plus, and then you can add straight down. These leading terms should always cancel each other out. 8a squared plus negative 8a squared, yeah, that cancels out. How about 2a plus 4a? Well, that gives me 6a, so that's my next term. And then the brother step is to bring down that 3 here. So we got the 6a, and then the minus 3 gets brought down. So father, mother, sister, brother, and then Rufus, your dog. That means repeat. So we have to repeat this process again. So we'll come down here to this little father step. We're going to figure out what you're going to multiply this by to get this. So that's going to be a 3. If you divide those two, you get a 3. That 3 goes up top. So let's put that up there. So that 3, that's a plus 3. That goes there. If you take the 3 times 2a minus 1, what would I get? What's that going to give me there? Yeah, 6a minus 3. Thanks, Gabby. So let's take that 6a minus 3 and put it in there. So 6a minus 3, and then 6a minus 3. So father, mother, sister would be the subtract step. Now when we subtract, the big thing here is to change the signs and add. So that becomes a plus, that becomes a minus, that becomes a plus. What do I get here for a remainder? What's left over? Yeah, 0. So it goes in evenly. Basically, this is a factor of this. You multiply this times this, you'll get this. So that's your answer. Your answer is just 4a plus 3. Nice. Let's try that again with a little bit less help here on this stuff. And that is with this one. So, first step is to figure out what you're going to multiply. My suggestion, when you do that step, when you figure out, oh, I'm going to take 2x squared times this, put that 2x squared above its like term. So in this case, you got a 2x squared and a minus x squared. Those are the like terms. That's where you want to put that term. The reason for that is pretty straightforward. It's going to help you understand when you're done. You're going to keep doing this until you get down to the constant term here. And after that, anything you have here is a remainder. And you'll write it like such. But for now, we're going to take the 2x squared times this term. So 3x minus 2, multiply those two together, and that's going to give me this term right here. So those two go together, 6x cubed minus 4x squared. And as before, kind of big note for ourselves. Change the signs and add. That's the number one mistake that I see people make. You're good at subtracting this one, but then you just add that and you end up with a -5 instead of a +3. So if you had a positive or a -5, then this next step would be kind of crazy. It'd be like, well, what do you multiply 3x by to get a 5x squared or -5x squared? And you're going to struggle because it would require fractions and you get mad at me. So if you're seeing something that has fractions, it's not that these problems can't have fractions. It's just that your instructor is nicer than that, and I don't give those to you. So if you have something that doesn't go in here evenly, there's a mistake. To get this 2x squared, I divided the leading term here by this one here. That gave me my 2x squared. What do I do to figure out what I'm going to multiply by next? What do I multiply 3x by to get 3x squared? X. So you're going to take that 3x squared, divide it by x, and that x is going to go up top. So I'll put that x there, and that x is a plus x. All right. Now I'll take that x times this. That's going to give me 3x squared minus 2x. So let's put that in its appropriate spot. So that's going to go right here, goes here. I'm trying to keep these things color coordinated for you. So that's going to be a 3x squared minus 2x. Change the signs and add. What's that going to bring down here when I change the signs and add? Anyone got my back on that one? Good. These are going to cancel out because when you make that a plus, that a minus, that's a plus, those cancel out. This leading term should always cancel out. If it doesn't, there's a mistake. And then 4x plus 2x gives me 6x. So looking good there. Last but not least, we got to figure out, well, what do I multiply by? What's my last step? What do you multiply by? See if you can fill this stuff in. This first thing is the ratio that you use to figure out what you're going to multiply by. The second one is doing the actual multiplication. See if you can't fill this step in. Give that a try. So this is just a little break here. You should be taking the 6x dividing by that leading term here. 6x divided by 3x gives me 2. I'll put that up here. This is telling me that this is the last step. I'm going to be done after I finish this step. Let's take the 2 times the 3x minus 2. And let's see what that gives me. Well, let's see. That's going to give me 6x minus 4. So I'll put the 6x minus 4 here. And when you change the signs and add, what do you end up with? 0. Yeah, nice, 0. Now, as far as an answer is concerned, you don't have to put 0 in terms of a remainder. You don't have to really mess with that. But if I wanted to be formal here, my answer would look like this. 2x squared plus x plus 2 plus 0 over 3x minus 2. So there's your remainder. And this is your quotient. And that's your divisor. So 3 different little parts in that if you needed that. Quite often you are going to get a remainder and you'll be asked to write it like this. Quotient plus remainder over divisor. That's what they'll write it as, or ask you to write it as. I know that was a little bit fast. Is there anything, any detail that I could add here? Maybe it's something I went over a little too fast for you. Alex?
I'm just confused about the changing the sign added part.
So the thing that's going on here is that you have to subtract these. When you're going from one level to the next, you have to subtract them. And if you notice, I put parentheses on all these things. So let's look at it again. So I had these parentheses, you're subtracting those. The reason for the change the sign and add is because that negative sign has to distribute itself to both terms. So when I had, for instance, right here, I had a 3x squared minus 2. A lot of people are good at subtracting this, but then they add this, and they end up with a 2x here as opposed to a 6x. So the change of signs and add is just my way of getting you to distribute that negative sign to both of those terms, or to subtract both of them. If you can do that in your head, that's great. Most people, when they make a mistake, it's because they forget to change the sign on this second term. So, great question.
So, and then on a test, will it be set up similar to this?
On a test, I'll just give you
just the numbers.
Here's what you get. You get that. All right, and the rest of it is kind of up to you.
Okay.
So, do you need to show me every little detail here? No. That a lot of people can figure these things out in their head. That's fine. They can also multiply that kind of stuff in their head. So mostly what I'll be looking to see would be something like this. So I wouldn't be surprised to see a problem on long division, but it's not my favorite either. So it just kind of depends on, when I write the test, if I've got enough room for a problem like that or not. I will say that I cover this kind of reluctantly. I don't. They're good problems and they're good applications for them. It's just that, there's other things I like to do. Anything else? All right. Thank you.